Hey there, algebra students. Today we need to talk about solving polynomial equations in factored form. And so let's review the zero product property. The zero product property says that if a times b equals 0, we're assuming that a and b are real numbers, right? So if a times b equals 0, then either a equals 0 or b equals 0. And so we solve for both instances, right? So say you have the equation c minus 3 times c plus 2 is equal to 0. This is already in factored form. We have something times something equals 0, so either this something equals 0 or that something equals 0. And so we set each of those things equal to 0. We have the c minus 3 equals 0 and the c plus 2 equals 0. And so for this one, we would add 3 to both sides to solve for c, right? We add 3 and we get c equals 3. Over here, we get c plus 2 equals 0. We subtract 2 from both sides of the equal sign, right? And we end up with c equals negative 2. And we're done with this. We've solved this equation. We have c equals 3 and c equals negative 2. And we're done. Now, things are not always this straightforward and easy, so we will try another question. We have to review factoring a little bit, right? And we haven't discussed all of the factoring just yet, but when we factor something, we always want to start by looking for the greatest common factor. What things multiply to 24h cubed? What are the factors of 24h cubed? Well, you could make a factor tree for 24. You could say, that 24 is 2 times 12, which is 2 times 6, which is 2 times 3. Can you see that there? And you could write that in as 2 times 2 times 2 times 3 times h times h times h. And here I'm going to erase the factor tree. And that's the prime factorization for the 24h cubed. What about for 8h? For 8, it's 2 times 2 times 2 times h. Now, I like to say, well, what do these have in common? What do these terms have in common? They have a 2s, another set of 2s, another set of 2s, and an h. Well, okay, so when we're factoring out the greatest common factor, we're going to pull the things that they have in common outside of the set of parentheses. And so 2 times 2 times 2 is 8, and they also share an h. So we'll pull an 8h out of the parentheses. And I'll say, I like to say we put the leftovers inside the parentheses. So what's left over from the 24h cubed? That's a 3h squared. Plus, well, 8h times what gives you 8h? That's just 1. We can't forget the 1. The 1 is very important. Now, we have 8h times the quantity 3h squared plus 1. We have factored out the greatest common factor from our original statement. And that is where we will stop with factoring out the greatest common factor. We have one more type of problem. Suppose you have something that looks like 7p squared equals 21p. And it says solve the equation. The very first thing we need to do is set it equal to 0. All right, so we're going to do that by subtracting 21p from both sides. So we would have 7p squared minus 21p equals 0. Then we need to ask ourselves, is there a greatest common factor that I can factor out? Or what do these two terms have in common? 7 and 21 are both divisible by 7. Both terms have a p, so we're going to factor out a 7p. So we're going to pull the 7p out of the parentheses, right? And we'll ask ourselves, well, 7p times what gives me 7p squared? You're right, just p. 7p times what gives me a negative 21p? Well, that would be a negative 3, right? 7p times negative 3 would give you negative 21p. So we set that equal to 0. And so then we can continue this problem by taking each chunk and setting it equal to 0, right? We have something times something equals 0. So either the 7p equals 0, which if we divided both sides by 7, we would still get p equals 0, right? Or the p minus 3 equals 0. And we would add 3 to both sides and get p equals 3. So your solution is p equals 0 and p equals 3. All right, that's it for today. Don't forget to show your work. See you next time.